properties of acids. We're going to start off with acids reacting with magnesium metal. So you can pause to look at the materials that are needed. I'm going to start with 2 test tubes with about 5 milliliters of one of 2 acids here, 1 molar hydrochloric acid or 1 molar ethanoic acid. And you're going to drop in about 5 centimeter strip, a 2-inch strip, firstly into the dilute hydrochloric acid. Let the reaction go for about a minute and stopper the tube lightly, so gases can still escape, but not all of them in a hurry. Please don't push the stopper in and don't seal the tube. And observe carefully the bubbling and any other observations that you may see. And as that reaction is underway, start with the next strip of magnesium into the ethanoic acid and compare what you see in this reaction to the one with the hydrochloric acid, the rate of reaction, the appearance, etc. Again, stopper that tube lightly. And then what you're going to do, you're going to test the gas. So you're going to get a wooden taper that you light the end. You're going to move the taper carefully across to the mouth of the test tube, and you're going to remove the stopper and immediately place the lighted splint in the mouth of the test tube. Here it's the HCl test tube reaction first, and you're going to note what happens. Then you're going to repeat it, being again careful with your flame, and test the gas from the mouth of the ethanoic acid test tube, and obviously compare if there are any differences. So, explaining what happens, acids react with reactive metals. You might do a range of metals to see which ones we're going to see react, and they do indeed react with magnesium. And it gives a salt and a gas, and we're testing the gas, and the gas pops with a lighted splint. So which gas is this? The gas is hydrogen. So what you're getting when you put a splint in there, you're getting a mini explosion with oxygen in the air. You've got the equation for that reaction. And hydrogen is the only gas which pops in that way, so it's a confirmatory test for hydrogen. The other product is salt, made of a cation and an anion. The cation in the salt depends on the metal. Here it's magnesium. And the anion depends on the acid chosen, the non-hydrogen part of the acid, and here it's the chloride ion Cl-. So the salt's name here is magnesium chloride. So which metals do acids react with? If you've studied, or when you study the electrochemical series and redox, you'll study the theory behind which metals are unreactive. And not surprisingly, they include metals you already know as unreactive, the jewelry metals, because you aren't going to make jewelry out of something that you want to last a long while out of metals that are going to corrode or react. And finally, we're going to look at an explanation of strong and weak acids. And this is for those with a knowledge of reversible reactions and equilibria, or indeed an interest in it. Saying both acids are uniprotic at 1 hydrogen ion per molecule, but HCl is a strong acid. So go down to the bottom of the page here. For strong acids, it's fully dissociated. And go up a little bit. For weak acids, it's only partially dissociated. It's reversible. But A here is the anion. Here it would be the ethanoate CH3COO- anion. And ethanoic acid is only a little dissociated into hydrogen ions and the ethanoate ions, but enough hydrogen ions for even what we're calling the weak acid, same concentration, but less dissociation into hydrogen ions. Those hydrogen ions will still react. And as the magnesium does react, it removes hydrogen ions, but the dissociation into ions will continue and will eventually all react if there's enough magnesium. So read that one carefully. And here is a link to go and investigate properties of acids. The link below, description of a lab reacting magnesium and zinc and copper with 4 different dilute acids: hydrochloric, nitric, sulfuric, and ethanoic. And there's the link.